we talk about the algorithm. So in this section, we talk about the graph. Graph, it is another data structure. So the first part, we introduction of the graph. So the graph, it is a data structure that consists of a set of the nodes or the vertices and a set of edges. So the set of edges describe the relationships among the vertices. So why we need the graph? So for example, if we use the Google Map, we want the direction from the, just for example, from the Austin to the Dallas. We want to find the shortest path. That is very simple because we can straight away from the Austin to the Dallas. But if the destination it is the Atlantic, so what is the shortest the path? For example, we can go through the Dallas and we can go to the Denver and then we go to the Atlanta, or we can go to from the Austin and then to the Houston and then to the Atlantic. So which way it is the shortest or which way it is more efficient? We need to convert our real world problem into the data structure, so into the graph. After that, we talk about the algorithm, and then we can find the shortest path from the one particular location to another location. And that is what we can use our the knowledge and the data structure and algorithm to resolve the real-time the problem. So we talk about the definition of the graph. So the graph is designed as the graph. It is the vertex and the edge, and then it is the vertex is the finite non-empty set of the vertex. This is the how the definition, and the edge set of the edges. And this is the one example. So you can find that in the graph we have the directed and undirected. So directed, that means, for example, from here you can find that this is the directed, easy. We have the arrow, that means 1 to 3, and the 3 equal to 1. But 11 can't to be the 1. So in our real example, so for example, we can find that, easy. From here you can find that is from the Austin, you see, from the Austin to the Houston, it is one direction, you see, but it is no error from the Houston to the Austin. So this is the we call the directed and the undirected. So the graph. And after that, we can learn something. For example, this is the directed and undirected, and how could we to represent it? Easy. So for example, when we represent it, we can do 1, 3. That means from the 1 to the 3, and the 3, 1 to the directed from the 3 to the 1. Okay, this is how we represent the graph. It's easy to understanding that. So based on that, we have another terminology. So we call the adjacent the nodes. That means two nodes are adjacent if they are connected by an edge. Okay. So 5 and 7. 5 it is adjacent to 7, and 7 it is adjacent from the 5. So as well as the path, a sequence from the vertices that connect two nodes in a graph, and complete the graph. Complete the graph, it is a graph in which every vertex is directly connected to every other vertex. So this is for the terminology. And after that, we call the complete directed the graph. So we can easily to see how to count the number of the edges. It is n times n minus 1. So we can easily to know that already. And after that, it is what we call the weighted is the weighted the graph. This is easy to understand that because from the one location to another location should has the different and the distance. So for example, from the Austin to the Dallas, it is 200, is it? And from the Dallas to the Washington, it is 1,300. So it's from Washington to the Dallas. So it is easy to understand that you have the different the weight of the graph. So based on the different weight, and we can use our algorithm to find the most efficient way from one particular location to another particular location. And that is what we used, for example, in our Google Map. So we can use the algorithm to find the recommendation path. And this is the after we talk about the weighted, we need to think about how to use our data structure to represent the graph. So we have the one possibility, it is the one-dimension array. Another is a two-dimension array. So two-dimension, it is a matrix, and one dimension, it is a array. So we can show you the examples. So with the one dimension, we use the linked list. So you just understand that we can use this data structure to represent it. The most popular way it is a two-dimensional way, and that is what that one is more easy to understand that. So we explain that to you. For example, when you think about the 0 is Atlanta, 1 is Austin, so we use a two-dimensional array. So for example, 0 and 0, it is the it itself, so it is 0, is it? And then 0 to what? You see here, is it? 0 to 5, it is 800. 0, it is Atlanta. 5, it is Houston, you see? Atlanta and Houston. Houston is here, is it? So 800, is it? And Atlanta to 6. 6 it is what? 6 is the Washington. So Atlanta to the Washington is 600, is it? So here it is 600. So we can easily to understand that how could we use this two-dimension array to represent the real world information. It is similarly, it is the one-dimension array. One-dimension array it is not difficult, but normally we use the two-dimension. But I can explain that to you. For example, from here, you see, 800 it is weight, you see. So index of the adjacent vertex. So this is the Atlanta, you see. So link with the 5 Atlanta, 5 it is what? 5 is Houston, you see. 5 is Houston, it's 800, you see. So 800. And point to the next edge node. Point to the next one is 6. 6 is the Washington, you see. 6 is the Washington, and it's 600. It's 600, you see. So this is how to use a one-dimension array to represent. But normally, for us to easy to understand that, so normally we use the two-dimension array. That is much easy, and we call this the matrix. And that is also normally could be resolved most of the problem. But when we talk about something, we talk about why we use the one dimension, because it is for the spice, the graph, its memory requirement, it is not high, so that's the reason for some simple problem we use a one dimension the array. But mostly if we need, for example, high demand of the memory and also it is good for the dense the graphics. So the memory requirement for the matrix is high. It's easy to understand that, is it? And the connection for the two vertices can be tested quickly. And but for the one way, it's easy to find another one. It's very quick. So this is the how to represent it the real world the problem. So currently, next part we will talk about the problem. So for example, how to find the path between the two nodes of the graph, and also we use the method and the depth first search and the breadth first search. We will talk about that to see how could we use the examples and to represent how the data structure useful. So next part we will talk about the depth first search an algorithm.